Bismillahirrahmanirrahim. Welcome to my channel, Science of Life with Dr. Mohammed Yusuf. Today we are going to talk about capillary exchange or microcirculation, and we will try to discuss in two lectures, inshallah. This is a long topic, so I'll try to discuss it in two lectures. So, microcirculation. But before that, one ayah from Holy Quran. A'udhu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. يا أيها الذين آمنوا ادخلوا في السلم كافة ولا تتبعوا خطوات الشيطان إنه لكم عدو مبين. يا أيها الذين آمنوا ऐ ईमान वालो उदखुलू फिस सिल्म काफ़ा, इस्लाम में पूरे के पूरे दाखिल हो जाओ. इस्लाम को जब अपनाना है तो फिर पूरे का पूरा अपनाना है. पूरा दीन हर एक के लिए. वला तत्तबिउ खुतवात शैतान, शैतान के नक्शे कदम की पैरवी नहीं करो. ये जो मर्जी का दीन, कन्वीनियंट दीन, नो, सारा दीन मेरे लिए है. और अपनी मर्जी करना या शैतान की मर्जी करना एक ही बात है. इन्नहु लकुम अदुव्वुम मुबीन, शैतान तो तुम्हारा खुला हुआ दुश्मन है. ईमान वालों, पूरे के पूरे इस्लाम में दाखिल हो जाओ, शैतान की पैरवी ना करो, वो तुम्हारा खुला दुश्मन है. तो दीन तो पूरे का पूरा हर मोमिन के लिए, हर मुसलमान के लिए, मेरे लिए है. इस पे पूरा अमल करना है. अगर इसके बावजूद कोताही हो जाए, कोई गुनाह हो जाए, कोई कमी रह जाए, उसके लिए तौबा है. अल्लाह गफूर रहीम है. लेकिन इंसान की अपनी कोशिश तो कि पूरा का पूरा दीन मेरे लिए और मैंने करना है. अल्लाह पाक हमें समझ अमल की तौफीक अता फरमाए, पूरे दीन के चलने वाला बना दे. आमीन. So we will discuss the microcirculation. We know the circulatory circuit, systemic. We are talking about systemic. Same, almost same is applicable with the pressure differences in the pulmonary circuit, where we will discuss the systemic, the greater circulation. It starts from the left ventricle and arteries, the bigger arteries and the arterioles, and then this is the red area which we are going to talk about today. Metarteriole or terminal arteriole, which will lead to the capillaries. There are pre-capillary sphincters and capillaries. The circulation here we are going to talk about. Then, of course, capillaries they join together to form veins and finally right atrium. But we are concerned with this is the area of discussion today: capillary exchange, especially capillaries. Capillary exchange, which between the interstitial fluid and the vascular fluid or plasma. Blood flow to the all tissues, which we have कुछ हमने बात पहले की हुई है. That is, each tissue can control its blood flow according to its requirements, its needs. Whatever the blood is required, that will be supplied. And this is mostly local control. We will discuss it in local control. We are going to discuss after a few lectures, 2, 3, 4 lectures. Blood flow is responsible for what? What is the need? What are the requirements of the tissues? That is the supply of all the requirements, that is through blood, and the removal of all the waste products. These are the requirements which, according to these, the blood flow will be controlled. So each tissue can control its own blood flow according to its needs. What are needs? Supply of the requirements, supply of the nutrition, oxygen, vitamins, hormones, electrolytes, etc., and the removal of the waste products. This is. If the waste products are more, they have to be removed, blood should come. If the more supply of oxygen, more supply of vitamins, more supply of nutrients is required, then more blood should come. So exchange between the blood and cell takes place through the capillary membrane, which consists of a single layer of endothelial cell. The exchange between the interstitium and this is the capillary membrane through which exchange will be taking place, and this is our point of discussion or the target tissue. There are 10 billion capillaries in our body, and total surface area across which the diffusion or the transport is taking place, and that is 500 to 700 square meters. Such a vast area through which the transport of these waste products requirement between the blood and between the interstitium is taking place. No cell is more than 20 to 30 micrometer away from the capillaries. This probably I talked about when there is edema, varicose veins. We talked about edema may cause nutritional deficiency to the cell because they become away from the capillaries. No cell, normally, no cell is away more than 20 to 30 micrometer away from the each capillary, जहाँ से nutrition supply है. The arterioles, smaller artery, which is known as nutrient artery, that is still artery, it branches several times, 6 to 8 times to become arteriole. फिर arteriole बनती है, arteriole diameter is 10 to 15 micrometer, yet, and has continuous muscular layer. अभी तक इसमें muscular layer is continuous. This is very richly supplied with the sympathetic यहाँ सप्लाई काफी है, स्मॉलर आर्टरीज में भी, यहाँ पे भी है. Arterioles also branch then 2 to 4 times, 5 times to form the terminal arteriole, which are known as metarterioles. What is the difference between arteriole and metarteriole? In arteriole, the continuous muscular layer, but in the metarteriole there are intermittent muscular layer. Continuously khatam ho gaye. Metarterioles, intermittent muscles are there, and then the final diameter of these metarteriole may be ranging between 5 to 9 micrometers. Capillary se thoda sa bada. So precapillary sphincters. Finally, the capillary metarteriole will then branch into capillaries, and finally the final muscle sphincter is at the beginning of the capillaries, and these are known as precapillary sphincters at the beginning of the capillaries. So precapillary sphincters can open or close. This is again very important aspect of the capillary circulation. That is, these precapillary sphincter diagram, we will see it in next slide, inshallah. So the precapillary sphincter can open, then the blood flow in the capillaries will be there, and if they close, they can completely block, obliterate. No blood flow in the capillary will occur when the precapillary sphincter is closed. So these precapillary sphincter can open or close the capillaries. So local conditions are responsible for this opening or closing of this precapillary sphincter. कब खुलेगा, कब बंद होगा, these are the local factors. Primarily, there is no supply, there is no sympathetic nerve supply to these precapillary sphincters. पीछे arterioles में है, लेकिन आगे नहीं, precapillary sphincter को supply नहीं है. So the local conditions control the opening and closing. What are those conditions? This is the local level of nutrients. Oxygen. If the oxygen is required, oxygen deficiency should cause the opening. If the oxygen is more, it should cause the constriction of this. So oxygen, carbon dioxide, hydrogen ion, maybe other metabolites, they control this opening and closing of the precapillary sphincter. If metabolites are more, they will open, and if nutrients are more, they may close. And if the nutrition deficiency is there, they will open. So we are going to see. So this is the local factor. These can be local factors, nutrients or metabolites. Requirements of the cell, उसके लिए खुलेंगे, and metabolites अगर पैदा होंगे, they will open. So these are the local factors. The types of this is a diagram of the capillary. This is the arteriole. Their muscular layer is continuous, but in metarteriole there are intermittent muscular coats. कुछ areas हैं जहाँ पे muscles नहीं है. And then the capillary start. This is capillary. At the beginning of each capillary, there are some muscles which are known as precapillary sphincters. These will cause the opening or closing. Vasomotion. We are going to define that phenomena of vasomotion. That is intermittent contraction of these precapillary sphincters as well as the metarteriole, etc., leading to the closure of the capillaries or opening of the capillary. That is known as vasomotion. आगे define करेंगे. So these are the continuous muscular coat in arteriole, and intermittent muscular coat, and the final muscular layer, muscular sphincter, is at the beginning of the capillary. These are the capillaries. So this is typical capillary bed. You can see again, we are going to describe. There is this is preferential channel, a ring road, a bypass road. When all the blood there are chances that all these capillaries may close. If the precapillary sphincter they constrict, they will close the blood flow in these capillaries and blood will be flowing. कहाँ जाएगा? Blood is coming in through the arteriole. Again, the precapillary sphincter बंद हो जाते हैं, where the blood should go? It will pass through the preferential channel back to the veins. There will be no supply to the tissues. Tissues को supply नहीं होगी. When it is no more required, if it is required, then the precapillary sphincter will open. So this is typically metarteriole and precapillary sphincter, and then finally these capillary will join together to form the venule. This is again another diagram from somewhere from Google. That is the arteriole and branching, and there are the capillary bed, and here you can see it is closed vasomotion. This is the open state when the precapillary sphincters are open. I should take this. When the precapillary sphincters are open, these are the closed as precapillary sphincters. These are the sphincters which will close, and if they close, the blood flow, there will be no blood flow. These capillaries are known as true capillaries. And that is the bigger channel is known as preferential. That is also a type, capillary type, but that is a preferential channel. So this is the preferential channel, this is thoroughfare channel. This diagram is writing it as thoroughfare channel or preferential channel, and the rest of the capillaries are, this is the preferential channel, thoroughfare channel, and these are the true capillaries. So this is typical capillary bed. Structure of the capillary wall, it is endothelial, single layer. That is the unicellular layer of endothelial cells. That's all. This is the total thickness, plus of course the basement membrane will be there. So it is the unicellular layer through which the exchange of the nutrients, exchange of the fluid, exchange of all the requirements, waste products will be taking place. So capillary wall, total thickness of this wall, capillary wall, endothelial cell, basement membrane is only 0.5 micrometer. 0.5 micrometer is the thickness of this capillary membrane, we can call it. Diameter of capillaries slightly less than those metaarterioles जो हमने बोला था, that is 4 to 9 micrometers. And you know the diameter of RBCs, that is about 7 micrometers. If it is 9, that can pass, but if it is less than 7, 8, then it has to squeeze through. That is, by diapetesis, you must have studied in the properties of WBC, properties of RBCs. They can squeeze themselves. So diameter of the capillaries is 4 to 9 micrometer, and the blood cells can squeeze through this diameter. इस diameter में वो squeeze करके गुजरते हैं. So this single layer of capillary membrane, there are pores in the capillary through which the substances can be transported. There are pores. One type of pore is the intercellular clefts. सेल्स के दो सेल के दरमियान जो क्लेफ्ट्स हैं, दो सेल के दरमियान थोड़ा सा 6 to 7 नैनोमीटर का फासला होता है, एवरेज 6 to 7 नैनोमीटर. देयर इज अ गैप बिटवीन these endothelial cells, adjacent endothelial cells. These are known as intercellular clefts, 6 to 8 nanometers, very tight in brain. These intercellular distance is very tight in brain. And they provide what we term as the blood-brain barrier. There are many substances which do not enter into the brain tissue or interstitial space, or also blood-brain barrier उसको कहते हैं, because of these tight intercellular clefts. ये थोड़े हैं, तंग हैं, tight हैं. And they are very wide in liver. Liver में बहुत wide हैं. इसमें बहुत टाइट है और लिवर में इतने वाइड है, इवन प्रोटीन कैन पास बिगर. मोस्ट ऑफ द कैपिलरीज में आमतौर पर प्रोटीन नहीं निकलते, ओनली स्मॉल अमाउंट ऑफ एल्ब्यूमिन लीक्स, ये हम डिस्कस करेंगे आगे. लेकिन लिवर में बिगर प्रोटीन्स कैन आल्सो पास थ्रू द कैपिलरी मेम्ब्रेन बिकॉज ऑफ द वेरी वाइड इंटरसेलुलर क्लेफ्ट्स. ये जो पोर हैं ये बहुत खुले हैं. एंड देन द सेकंड टाइप ऑफ पोर्स, दीज आर आल्सो पोर्स इन द कैपिलरी. दे आर in the इंटरसेलुलर नहीं, सेल के अंदर दे आर फॉर्म्ड बाय द कोएलेसेंस ऑफ द वेसिकल. देयर आर वेसिकल्स इन द फ्लूइड, दे जॉइन टुगेदर टू फॉर्म अ चैनल इनसाइड द सेल. सेल के अंदर चैनल क्रिएट हो जाए, डायग्राम में आके आ जाएगा. दे आर वेसिकुलर चैनल्स, डिफरेंट स्मॉल वेसिकल, दे जॉइन टुगेदर टू फॉर्म अक्रॉस द सेल. वो वेसिकल बन जाता है. इट मे अपीयर, इट मे डिसअपीयर अगेन. सो द vesicular channels formed by the coalescence joining together of the different vesicles. So they are more developed in glomeruli, in kidneys, where the glomerular filtration takes place. ये वाले channel वहाँ पे बहुत important है. They are well developed there. So diagram देख लें. This is one cell. This is intercellular cleft, which is tight in brain and very wide in liver, जो अभी हमने discuss किया. And these are different vesicles, and these vesicles they can join together to form a channel like this. This channel has been formed. Channel has been formed. So the channel like this has been formed. So this is the vesicular channel and the intercellular channel. And these are different vesicles. And this is basement membrane. This is one cell. Nucleus नहीं दिखाया. This is only a diagram. Nucleus नहीं दिखाया. आगे कैसे? आगे दूसरी diagram nucleus वाली भी आ जाएंगी. So this is through which all the exchange is taking. This is the capillary membrane, जिसकी thickness हमने क्या 0.5 micrometer. This thickness is 0.5 micrometer. This is again a diagram. This is the capillary nucleus is there. This is endothelium, and these are there are the boundary between the endothelial cells. These pores and the clefts, they can join together. These cells join together to panocytic vesicle. They can join together to create a channel. तो पेनोसिटिक वेसिकल वो पेनोसाइटोसिस भी करते हैं, और दे कैन बी ट्रांसपोर्टेड, बट चैनल्स में बी फॉर्म थ्रू विच दी सब्सटेंसेस कैन बी कैरीड आउट. So this is again the boundary between two cells, and these are the different channels. Fenestration are pores which have been created by the coalescence of the different vesicles. So this is the capillary membrane, structure of the capillary membrane. Brain में there is the tight junctions. The junctions between the cells are tight junction, which results they don't allow easy transport through. And this is known as blood-brain barrier. Tight, कौन से intercellular clefts बहुत tight हैं, and many substances cannot be transported into the brain. This is known as blood-brain barrier. Liver उल्टा हो जाता है. Liver में these are very wide and the very permeable, very wide open clefts. और these intercellular clefts space है, ये बहुत wide open. Even bigger protein, यहाँ पे big लिखना, even bigger protein can pass in and out. बाहर भी जा सकते हैं, अंदर भी आ सकते हैं. Like fibrinogen, all the plasma protein you must have studied. All the plasma proteins are synthesized in the liver. Liver के अंदर बने हैं, तो they will enter into the blood. Blood में कहाँ से दाखिल होंगे? Through these penetration, through these wide pores, so they can enter into the blood, and they can re-enter into the liver. So they can protein pass in and out. Then glomerular capillaries, where the coalescent, those vesicular channels are more important, very permeable. Large amount of the filtrate is formed. आपने सुना होगा 180 liters per 24 hours of filtrate can occur in the glomeruli. So large amount of filtrate is formed because of the very high permeable glomerular capillaries. उसको देखेंगे किडनी when we discuss kidney, उसमें भी देखें. तो these are, यहाँ पे हमें पता है, they are very permeable because of the large number of those intercellular vesicular clefts, as well as the intercellular clefts are also bigger, उसमें भी बड़े. But no protein filtration. This is again important. This is not like liver की तरह नहीं है. They are very permeable, but not permeable to protein. All the this filtrate to 180 liters per 24 hours जो बोला है, 125 ml per minute बन जाता है. That is protein free filtrate, PFF. There is no protein. These are very highly permeable capillaries, but they don't allow protein. Even albumin cannot pass. In the most of the body tissue, some amount of albumin is filtered. लेकिन यहाँ पे albumin भी filter नहीं होती. Well, no protein is filtered. So some capillaries are large, preferential channel, as we have seen, through which the blood they are always open. And there are smaller capillaries which are true capillaries, which are guarded by the precapillary sphincter. If the precapillary sphincter is closed, there will be no blood flow. Then if this is open, blood will be flowing. Precapillary sphincters at the origin of each true capillary. These precapillary sphincter can sphincter open. Sorry, the spelling open and close according to the needs. This is open. P is missing. So these precapillary sphincters can open and close according to the needs of the tissue. So this is precapillary sphincter में उसको हम देखेंगे. This phenomena is known as vasomotion. आगे define करेंगे. So typical, this is the preferential channel and the true capillaries, and the vasomotion में ये बंद भी हो सकते हैं, खुल भी सकते हैं. ये भी डायग्राम हमने पहले देखी हुई है. टू प्रेफरेंशियल चैनल और ट्रू कैपिलरीज को देखने के लिए, वेजोमोशन के लिए ये याद रखें. दिस इज ओपन एंड दिस इज क्लोज. दिस फिनोमेना इज नोन एज वेजोमोशन. आ गया. दिस इज वेजोमोशन. व्हाट इज वेजोमोशन? इंटरमिटेंट कंट्रैक्शन एंड रिलैक्सेशन ऑफ द मसल इन द मेट आर्टरियोल एंड प्री कैपिलरी स्फिंक्टर्स. मेटाट्रियोल भी काफी वेजोमोशन में दोनों बंद होते हैं. मेटाट्रियोल की मसल भी टाइट हो जाते हैं, बट लेकिन फिर वो कंप्लीट क्लोजर ना भी करते हो. प्री कैपिलरी स्फिंक्टर, ट्रू कैपिलरी के जो स्फिंक्टर है, दे कंप्लीटली क्लोज द कैपिलरी. सो इंटरमिटेंट कंट्रैक्शन एंड रिलैक्सेशन ऑफ द मसल्स इन द मेटाट्रियोल एंड प्री कैपिलरी स्फिंक्टर इज नोन एज वेजोमोशन. ये इंटरमिटेंसी है. इफ द ब्लड इज रिक्वायर्ड इट विल ओपन. नॉर्मली भी होता है बंद क्लोज बंद खुलते खुले बंद. सो इन द ट्रू कैपिलरी ब्लड इज नॉट अ कंटिन्यूअस फिनोमेना. blood flow is not continuous. It is intermittent blood flow. कभी बंद होता है, कभी खुलता है. So this is the this is vasomotion. Intermittent blood flow in the capillaries. ट्रू कैपिलरीज में हर वक्त ब्लड इंटरमिटेंटली फ्लो करता है. ये बंद खुलते रहते हैं. वेजोमोशन इसी को कहते हैं. कंसंट्रेशन ऑफ ऑक्सीजन प्राइमरीली, बाकी चीजें भी, बट कंसंट्रेशन ऑफ ऑक्सीजन इन टिश्यू रेगुलेट्स वेजोमोशन. ये बड़ा रेगुलेटिंग फैक्टर ऑक्सीजन की कंसंट्रेशन है. इफ ऑक्सीजन इज लेस दे विल ओपन. Hypoxia causes the opening of the precapillary sphincters and muscle of the intermittent relaxation of the metatriolar muscle. उनको कर. And if oxygen is more, it is not required, then they will close. Precapillary sphincter will be tightened and the metatriolar will be, again, their diameter will be reduced. So concentration of oxygen in the tissues regulates this vasomotion. Metabolic rate of the tissue will affect the oxygen level. If the metabolism in the tissue is more, then of course oxygen will be deficient and it will remain open. Capillary will remain open as long as there is more metabolism in the tissue. If the metabolism is slowed down, there is no more requirement of the oxygen. It is not being utilized quickly. Then the oxygen level is more, so it will close the precapillary sphincter. So metabolic rate of the tissue affects the oxygen concentration in the tissue. तो ऑक्सीजन कंसंट्रेशन ज्यादा होगी, it will favor in the closure. Vasomotion will be in the form of closure of the capillary, true capillary. And if the oxygen is deficient, hypoxia compared to the metabolic needs, then there will be continuous blood flow. It will open. Exchange between the blood and the interstitial fluids occurs by, number one, diffusion. Diffusion of substances, what is that? That is from higher concentration to lower concentration. Oxygen is more in the blood, in the arterial blood, and the oxygen is being utilized in the tissue, so oxygen level is always low in the interstitium, so oxygen is being carried from the capillary into the interstitium. And carbon dioxide is being produced by the tissues, and its concentration is more in the interstitial compartment, so its concentration gradient is from the interstitium into the capillary. So diffusion will be there. Diffusion is the lipid soluble substances. They directly pass through the whole of the endothelial cells. Lipid soluble के लिए तो problem नहीं है. They can cross the cell as a whole, पूरी surface of the cell पूरी, because they will enter in through the क्या कहते हैं, what is that, lipid bilayer. लिपिड बाइलर जो सेल एंडोथेलियल सेल की सेल मेम्ब्रेन है, उसके अंदर जाके दूसरी तरफ निकल जाएंगे. So lipid soluble substances, they directly through the cell, पूरे cell के अंदर से जाएंगे. And then transcellular transport. Transcellular transport इसको कहें, diffusion is taking place. cell के oxygen, carbon dioxide, and the diffusion rate is very fast. जो भी lipid soluble substances हैं, because whole of the surface of the वो जो 500 to 700 square मीटर जो पूरी बॉडी की कैपिलरीज को का है, whole of this surface is available for the transport of lipid soluble substances. So diffusion rate of these substances is very fast as compared to the lipid insoluble substances, जिनको हम water soluble के नाम से बोलेंगे. Lipid insoluble substances, diffusion from the whole of the surface area of the capillary membrane occurs. So this is transcellular diffusion. ये होती है. Then water soluble substances, their diffusion substances, that is through the intercellular clefts or the vesicular pole, उससे होगा. Intercellular clefts and pores से होगा. That is उसका total surface area as compared to the whole of the surface area of the capillary membrane is only 1,000 of the total surface area. Only 1,000 of the total surface area, so that will be very low. Rate of diffusion will be very low. But again, water soluble substance, abhi word of caution, that is this low rate. ये भी कितना है आगे हम देखें. वाटर की मूवमेंट इज वेरी फास्ट, आगे हम देखेंगे. बट water soluble rate is much lower than the fat soluble substances diffusion rate. Water, sodium, potassium, chloride, glucose, these are the water soluble substances, and water itself. So their transport is much less, as much slower as compared to the lipid soluble substances. But word of caution कैसे? Water transport is so quick, even this low rate as compared to the lipid solubles. 80 times exchange of water as compared to the linear movement. Despite this, only 1,000 of the total surface area. क्या कह रहे हैं? That is, if 1 ml of water is flowing from this end of the capillary into this end, 1 ml. This 1 ml, the water transport across the capillary, 80 ml of water in and out will be taking place. 80 times exchange of water as compared to the linear movement. ये example के लिए मैंने कहा 1 ml of the water अगर is moving from one end of the capillary to the other end of the capillary, इस दौरान में this water will be 80 times exchange across the capillary. So this rate across the capillary is so fast, though the total surface area is much less. So lipid soluble का आप सोच लें, that is so fast, that will be very fast as compared to the water. So this transport across the even this very small surface area compared to the whole of the endothelial surface, it is sufficient for the transport of water and water solubles. That is, when water is moving in this direction, water is moving across the capillary as well. 1 ml linear direction में move करेगा, उस दौरान में 80 ml अंदर बाहर हो चुका होगा. So it is very fast. That is diffusion across the membrane. Arterial and venous end पे जाने पे water is moving in that direction, but it is moving in and out, and that rate is 80 times than the linear movement. So it is very fast. तो एक और चीज यहाँ पे इस डायग्राम में नजर आ रही है, which we will talk about probably in next lecture, और उससे भी अगले लेक्चर में बात करेंगे. This is the lymphatic capillaries. There is transport of many substances through the lymphatics as well. इसको हम डिस्कस करेंगे. So lymphatic capillary को, these are the blind tube capillary, ये तो continuous नहीं होती. They will take some water, some things from the interstitium into the blood again. These are the lymphatic capillaries. This transport across the capillary membrane is affected by the molecular size. जितना बड़ा मॉलिक्यूल होगा मुश्किल से मूव करेगा. Bigger protein, they do not move. Fibrinogen and the globulin, they usually don't go out, and only albumin can pass out. So the size of the molecule, substance, molecular weight, and permeability. If we take the permeability of water, the molecular weight of which is 18, two atoms of hydrogen and one atom of oxygen, that is water. Oxygen's molecule atomic weight is 16, hydrogen ka 1 hai, so it is 18. To hydrogen. So 18 molecular weight. If we take this permeability as 1, इसको हम 1 consider कर लें, तो इसके मुकाबले में हम देखेंगे कि इंक्रीज मॉलिक्यूलर साइज विल अफेक्ट द परमेबिलिटी. अगर परमेबिलिटी उसको देखेंगे, फॉर एग्जांपल सोडियम क्लोराइड, इट्स मॉलिक्यूलर वेट इज 58.5. That is one sodium and one chloride. Molecular weight will be 58.5, and its permeability as compared to the permeability of water will be 0.96. कम होगी. Molecular size has increased and the permeability has reduced. Now और देखिए यूरिया, its molecular weight is almost, इससे भी थोड़ा सा बड़ा है. यूरिया molecular weight is 60, its permeability is 0.8 और कम होगी. So molecular glucose जिसका molecular weight is 180, so the permeability is only 0.6, कम होती जा रही, आधे से जरा ज्यादा रहेगी वाटर की कम. एंड दी सुक्रोज जिसका molecular weight is 342 and its permeability is only 0.4, आधे से भी कम हो गया as compared to the water permeability. And the inulin molecular weight of 5000 and the permeability is only 0.2, only 20%. अगर परसेंटेज में देखें वाटर के मुकाबले में, it is only 20%. That is 100%, तो ये 20%. Myoglobin, the myoglobin, a big protein, जो muscles में protein होता है, if it is there and its molecular weight is 17,600, its permeability is only 0.03. इतनी थोड़ी permeability. अब और आगे जाएं, hemoglobin molecular weight you must be knowing, it is 68,000 molecular weight, or its permeability is again very low, 0.01 as compared to the water. And albumin molecular weight is 69,000, molecular weight बढ़ गया, उसकी permeability और भी कम है, 0.001 as compared to the water. So molecular size affects the permeability across the membrane. इसी के मुताबिक उसकी transport भी होगी. Diffusion across the capillary membrane. Capillaries in different tissues have different permeabilities. अभी हमने बात की ना, ब्रेन वाली कैपिलरीज और हैं, लिवर वाली कैपिलरीज फेनेस्ट्रेशन उनके बहुत खुले हैं, and the glomerular capillaries, so permeability differ in different tissues. Liver sinusoids are very permeable to even bigger proteins. All the plasma proteins, they can pass through the capillaries. वो इतने आसानी से अंदर बाहर होते हैं across the capillary membrane, liver sinusoids में. And the renal glomerular capillaries की भी हमने बात की है. Permeability for water and electrolytes is 500 times more than the permeability in the muscles. Muscles के अंदर जो capillaries हैं, glomerular capillaries उसके मुकाबले में 500 times more permeable है. So different tissues में capillary permeability differ. इसके लिए हम एक capillary coefficient calculate करेंगे अभी हम. So capillary permeability differs in different tissues. Brain की capillaries को हमने बात की हुई है. The concentration gradient determine the net rate of the direction of the fluid. ये तो सीधी सी बात है. Concentration gradient के मुताबिक, if the concentration gradient is more, there will be more. If the concentration gradient is less, then the net transport will be less. Or the direction of the concentration gradient, if it is in this direction, diffusion will take place in this direction. If it is in opposite direction, misal दी है, oxygen is transported from the capillaries into the interstitium and carbon dioxide is transported from the interstitium into the capillaries. Interstitial fluid कहाँ से बनता है? That is filtration and diffusion from the capillaries. ये सारा बना यहीं से है. All the interstitial fluid is formed from the filtration from the capillaries, and it is low in protein. Interstitial fluid में protein क्यों कम है? Because we have seen the permeability of the capillaries to protein is only albumin, which is the smallest protein in the plasma, is only 0.001 as compared to water permeability. So that's why the proteins are not filtered through the capillaries. Very small amount of albumin is filtered. So that's why the protein contents in the interstitium is very low as compared to plasma. And In the interstitium, there are collagen fibers, there are proteoglycans, mostly hyaluronic acid in the interstitium. ये मौजूद हैं and water is absorbed to them. ये जो प्रोटियोग्लाइकान एंड कोलेजन फाइबर है इनके साथ वाटर इज एब्सॉर्ब टू इट एंड बिकॉज ऑफ दिस इज द जेल स्टेट ऑफ द इंटरस्टिशियल फ्लूइड इट इज नॉट फ्री फ्लूइड it is not freely movable fluid. It is gel state of the fluid. There are some vesicles जहाँ पे revolutes of the fluids are there free fluid के, लेकिन ज़्यादातर fluid is in gel state and fluid does not flow freely. It diffuses through gel. Fluid कहते जो भी water है gel state में है. This is interstitial fluid is then because the proteoglycan and collagen fiber hyaluronic acid के साथ water is absorbed and it is not freely movable. Diffusion occurs through this gel as well. Free fluid vesicles are also there, but they are less than 1%. Less than 1% in the gel. ये आगे diagram में आगे edema जब होगा, edema जब भी होगा, then this free fluid is increased and you must have seen the edema. If edema occur, then this free fluid may reach to 50%, which are only less than 1%. लेकिन edema जब होगा तो 50% of the fluid will be in this free form, and that's why that pitting edema occurs in most of the cardiac failure की जो हमने कुछ जिक्र किया था हमने, तो pitting edema will occur. This is the gel state of the fluid. Capillary से जो interstitial fluid है, that is the glycogen and the glycogen fiber and proteoglycan. There, water is absorbed to it and it is not freely movable. This fluid is freely movable. This is the rivulets of this free fluid. ये भी है. And edema में ये ज़्यादा होता जाता है. So this is how the transport can take place, and we will continue this discussion. Next lecture will be very important. What are the forces which are responsible for the transport of this in microcirculation 2? We will see what are the forces which will cause the filtration or absorption of this fluid. So fluid is being formed, it is being filtered, and it is being absorbed, and this is the balance is maintained between the filtration and this, and balance is in favor of more filtration, and some fluid will be carried by the lymphatics जो मैंने बात की थी. So we will discuss in next lecture inshallah in microcirculation 2 next video में. Hope you are following me. If you have got some questions you can ask and questions, and hope to see you. इसको share भी करें and subscribe भी करें and दूसरों तक पहुंचाएं भी. So hope to see you in next video. Thank you very much.